Since 2006, Fluid SA has been developing its patented technologies for autothermal carbonization of biomass. In 2016, it built the world's first energy recovery plant from all kinds of biomass. It is a model example of the use of carbonization processes, which in April 2018 was positively evaluated by the Institute of Power Engineering in Warsaw. The technological process enables continuous polyproduction 24 hours per day, 7 days a week. Modular technology allows to optimally regain energy from biomass in every part of the world, including these ones without access to the power grid. Medium-sized energy recovery facility allows to process up to 6 tons per hour of biomass with an average humidity of 45%, producing up to 2 tons per hour of biochar fluid brand with calorific value not lower than 24 megajoules per kilogram, to 0.4 megawatts of renewable electricity, 0.8 megawatts of renewable heat, 0.2 megawatts of cold. The technological process begins at the biomass reception point. Biomass is transported to dryers via an integrated feeder system. Along the way, the screening system and metal and stones detectors separate the fraction which doesn't correspond to the technological assumption. Dryers use the post-production heat. The task of dryers is to reduce the biomass moisture content to less than 30%. Then, the biomass is transferred to each reactor individually. Years of fluids experience have provided sufficient knowledge to carbonize any type of biomass, which allows to significantly reduce production costs. Fluid has conducted analysis on more than 80 different types of biomass, with partners from each continent. The results of the analysis are publicly available. The technological process always begins with warming up the reactor. The annealing of the reactor is done by the flue gases generator. Hot air and flue gases from the oil burner flow into the interior of the reactor tangentially to its inner ceramic casing. After reaching about 650 Celsius degrees inside the reactor, the oil burner turns off and at the same time the biomass is fed to the retorts. The reactor's internal hopper keeps the heated, dry biomass in the atmosphere of insufficient air. From the inner hopper, the biomass moves to the retorts. Hot and dried biomass, when moving forward, is subjected to an intensive process of further heating without oxygen. Partial degassing of light hydrocarbons takes place. These gases, through the holes in the retorts, escape in the interior of the reactor and are burned in the hot air, which as a result of tangential inlet to the reactor moves swirling around the inner wall of the reactor, warming up at the same time. The combustion of hydrocarbons escaping from the retorts create autothermal conditions of the process, without the need for further heating with the oil burner. The roasting process in retorts without access of oxygen causes carbonization of biomass. The process is carried out in an automatic control system with time and temperature selected in such a way as to achieve partial degassing and to increase the amount of bound carbon element up to over 65%. The whole process is fully measured and automated. The plant's work is supervised by an operator who can control the entire technological line from the operator's room and can produce biochar with parameters selected by the recipients and the desired amount of heat. In the hot flue gases from the autothermal process, significant thermal energy is accumulated. The plant recovers it through the system of exchangers and uses it in the technological process, drying the biomass and/or the briquetted biochar, among others. With this heat, it warms industrial and office buildings and sells surpluses to the municipal network. In the case of our plant, we sell surpluses to the thermal system in Sędziszów. The energy recovery facility is also equipped with the highest class flue gases filtration system. As a result, 99.99% of the solid particles is captured. The flue gases purification system is designed to extract flue gases through the chimneys as well as the steam generated during the biomass carbonization. The high compressed steam is used for the production of renewable electricity. The energy recovery plant has been equipped with a 0.4 megawatts generator. The technological line is equipped with a station of production of gold, which in Poland is used in the technological process. In countries such as Mexico, Indonesia, or Australia, it can be a product sold like electricity or heat. The product of the process is a fuel with the trade name Biochar fluid brand. It is a renewable fuel, ecologically clean with high energy density. This fuel is spilled from the bottom retorts into a sealed tank, from where it is picked up by a screw feeder cooled by water. The purpose of this feeder is to cool the biochar to a temperature below 40 Celsius degrees and to move into the installation of filling storage containers, big bag type. The energy recovery facility is also equipped with a quality control station, which task is to verify biomass and biochar parameters on an ongoing basis. Powdery biochar is packed in big bag type containers of 500 kilograms and 200 kilograms. In the meantime, briquetted biochar is packed in 5 kilograms and 10 kilograms packages. The plant is also equipped with briquetting and packaging lines. Briquetted made from biochar fluid has many advantages over charcoal. The most important one is the cleanliness of the fuel, which raises the value of prepared meals. The briquette is used as a fuel for barbecue, shisha, or household fireplaces.